Good morning. Here in this lecture we are going to discuss the first topic from the physics, that is rotational dynamics. Now the name itself gives idea about that, which content we want to discuss under this topic. So we'll start the introduction for this topic. So in the introduction, first we can consider the terminology which is given here as the rotational and dynamics. We know in the physics there is a one branch in which you can study the objects which are in motion and the forces acting on the object. So this is the one branch of the physics which is called as the mechanics. So you will find the study of the object which are in motion and the forces acting on them. It is the one branch of the physics. Again, this mechanics, it is divided into two branches. So the first branch of the mechanics, it is called as the statics. It is called as the statics. And the second branch, it is called as kinetics. So this mechanics, it is divided into two groups. One is the statics and another is the kinetics. Now what is meant by the statics? That is the study of the object at rest. म्हणजे स्टॅटिक्स मध्ये आपण जे ऑब्जेक्ट रेस्ट पोझिशनला आहेत त्यांचा अभ्यास आपण करणार आहोत. दॅट इज द स्टॅटिक्स. इन केस ऑफ द कायनेटिक्स वी वॉन्ट टू स्टडी द ऑब्जेक्ट which are in motion. So in this branch we want to do the study of the object which are in motion. Again, this kinetics is divided into two groups. Kinetics is divided into two groups. So you will find the first branch is called as kinematical. It is a one branch of kinetics, and another branch is dynamics. Now what is the meaning of these two terminology? Kinematical means we want to study the object which is in motion without considering their causes. म्हणजे या भागामध्ये वस्तू मोशन मध्ये असणार आहे, पण त्या मोशनच्या पाठीमागचे कॉजेस आपण विचारात घ्यायचे नाही. Without considering the causes means in kinematical branch we cannot use this quantity, the force quantity. It is not observed in case of the kinematical one. The next branch is given as the dynamics one. Now what is mean by the dynamics? That is the study of object in a motion with considering the forces acting on the object. Means in case of the dynamics, here we are using the concept of force which is acting on the object, or here we are also considering the cause of the motion. So regarding to this classification, you will get this word dynamics. It is given here. Means in this topic we want to explain about the motion of the object with their causes. So this is the explanation related to this dynamics. So you will find this is the explanation. Secondly, when we consider about this rotational one, we know there is a terminology which is called as motion. Now we know the motion is defined as the change in position of an object with respect to surrounding in a given interval of time. So this is the definition for the motion. Now when we consider this motion, you will find there are different types of motion. So here we can consider the three types of the motion. The first type is called as rectilinear motion. So the first type is called as rectilinear motion. The second type is called as the rotating motion. Rotating motion. And third one, it is called as the vibratory motion. Vibratory motion. Now this rectilinear, it is also considered as the translational motion. Translational motion. So you will find here translational, rotational and vibratory. These are the main three types of motion. Now when we are going to consider these different types of motion, you can remember the examples of all these three. Now when we consider about these different types of motion, we want to explain the important part, that is the first type of motion, that is given here as the translational motion. Now when we consider about this translational motion, then this translational motion, it is again divided into three types. Again it is divided into three types. Translational motion. First is called as linear motion. First is called as linear motion. Second is called as circular motion. Second is circular motion. And the third one, it is called as the random motion. So you can observe this is a classification regarding to the motion. That is motion are divided into mainly three types: translational motion, rotating motion and vibratory motion. Again this translational motion, it is divided into three types: linear motion, circular motion and random motion. I will give here the one example due to which you will get idea about this motion. What is mean by the linear? Linear motion, it is also called as rectilinear motion, means in which the object is moving along a straight line. So we can consider here, for example, motion of a football. Motion of the football, it is moving along a straight line. So this is the example for the linear motion. In case of the circular motion, the object is moving along the circumference of circle. We can take the example, that is motion of moon around the earth. Motion of moon around the earth. So this is the example related to the circular motion. And the third one, that is the random motion, in which we can consider the motion of insects and birds. Insects and birds. So you will get, this is the classification. So motion, this is a very important term, ज्याला मराठीमध्ये आपण गती असं म्हणतो. So these are the three different types. You will find these rotational. This is nothing but the rotating motion. Rotating motion. This is the second type that we want to discuss here. That is the rotational motion. In case of the translational motion, we have seen the classification of this. Now here the name itself gives idea about that. we want to discuss the rotational motion. Now here again, if you observe the second type of motion, it is given as the rotational motion. So we are going to explain about this motion also. This is the second type of motion in which the object is moving about its own axis. So you will find, suppose this is the rigid body and this is the axis of rotation. This is the axis of rotation, and this rigid body, this is rigid body, it is rotating about this axis. So you will find this motion, it is called as the rotational motion. For example, here we can consider that is a top. So if you observe top, it is moving all the particle about its own axis. So this is called as the rotational motion. For example, if we consider this particle, one particle, this is the distance of this particle. So it will cover, when this object is rotated, then you will find it will perform such type of circular motion. So you will get idea about this. This rigid body consists of large number of particles. So that each particle having a circular motion about its axis of rotation. And you will get idea about this rigid body also. What is the rigid body? For example, stone. Rigid body याचा अर्थ आपण इथं stone हे पण उदाहरण या ठिकाणी घेऊ शकतो. So the distance between the any two particles, it will remains the same or constant. It is called as the rigid body. So you will get idea about this rotational motion. In case of the rotational motion, axis of rotation, it plays very important role. So you get the idea about this rotational motion, and the name itself gives those points we can consider in this topic. Okay. Now we are going to the next point that already we have seen the different types of motion. So we are going to compare the two motions here so that you will get idea about or the correlation between linear motion, which is also called as the rectilinear motion, and another is called as the circular motion. So here we want to compare these are two motions so that you will get idea about this. Circular motion मध्ये ज्या कन्सेप्ट आपण यूज करणार आहोत, इट इज फॉर द सिंगल पार्टिकल, आणि पुढे जाऊन लार्ज नंबर ऑफ पार्टिकल साठी आपण विचारात घेणार आहोत. सो इट इज ऑल्सो यूज्ड फॉर द रोटेशनल मोशन. ते आपण रोटेशनल मोशन साठी त्याच टर्म्स वापरणार आहोत. सो दिस इज द व्हेरी सिंपल मोशन इन विच द ऑब्जेक्ट इज मूव्हिंग अलॉन्ग अ स्ट्रेट लाइन. सपोज दिस इज द ऑब्जेक्ट which is considered at rest position. So let it be, it is the initial position of the object. When the force is applied, you will find this body will set in motion with velocity v. It will cover a certain distance within the factor of time t, and suppose it will reaches to the capital B, which is called as the final position. Now if you observe the distance between these two, it is a denoted like letter S, which is called as the displacement. So this is a very simple motion. रस्त्यावरून जाणारे एखादं वाहन आहे तर तेही उदाहरण आपण लिनियर मोशन साठी विचारात घेऊ शकतो. So this is the one block in which you can observe when the force is applied, then there is the displacement. Now here the each symbol having a specific meaning. U is called as the initial velocity, V is called as the final velocity, F is the external force which is applied on the body, S is called as the displacement, and T is called as the time. Now when this object is moving with the uniform acceleration. Already we have seen this uniform acceleration. Then you can find out the relation between u, v, s, a and t. So all these correlation, it is called as kinematical equation. These are called as the kinematical equation in linear motion. Already we have seen these kinematical equations. That is, first equation is called as v is equal to u plus at. Second equation is called as s is equal to ut plus half at square. And third equation is called as v square is equal to u square plus 2 times of as. So these are the three kinematical equations which can give the correlation between these four. Now all the equations are given in the scalar form. याला आपण स्केलर फॉर्म मधले कायनेमॅटिकल इक्वेशन्स म्हणणार आहोत. स्केलर फॉर्म, it is a scalar form. So you will find these are the relations different. So this v is the final velocity, u is the initial velocity, acceleration, time. Here s is the displacement, initial velocity, time, acceleration, time, final velocity, initial velocity, acceleration and displacement. So already you have seen all these kinematical equations that is related to the linear motion. लिनियर मोशनशी रिलेटेड जी नोटेशन्स आपण वापरतोय ती आपण प्रामुख्याने लक्षात ठेवा. दॅट इज द एस, इट इज कॉल्ड ॲज लिनियर डिस्प्लेसमेंट. सो यू शुड रिमेंबर द लिनियर वर्ड इज यूज्ड इन केस ऑफ the straight line motion. So linear displacement, it is denoted with s. Secondly, linear velocity, it is denoted with u and v also. So we know u is called as the initial velocity, initial linear velocity, and v is the, that is linear final velocity. Thirdly, here we are going to use a, which is called as the linear acceleration. So these are the symbols which are used in case of the linear motion. So these are the kinematical equations. Now when we consider about the circular motion, this is the special type of motion in which the particle is moving along the circumference of circle. So you will find this is the pictorial representation for the circular motion. Now here we can show the particle is moving in anti-clockwise direction. Let O be the center of this circle. Now around us we have seen the number of examples in which you can observe the circular motion. For example, motion of the moon around the earth, motion of the planetary system around the sun, in which we can consider this moon or all the planets, they are in a single particle. So also here we can consider, suppose this is the single particle, say it is P. So now this is the position of the particle. Now how we can define this circular motion? The motion in which the particle is moving along the circumference of circle, it is called as the circular motion. Now this diagram will represent the particle is moving along anti-clockwise direction. For to understand the circular motion, you should know certain terms. First is called as the radius vector, which is denoted as r bar. Which is denoted as r bar. So if we draw the such type of vector, that is from center of circle to the position of the particle, it is denoted as r bar, which is called as the radius vector. Now this particle is moving in anti-clockwise direction. So if we consider in a time t, this particle also covers certain distance. suppose it will reach here, suppose this point is Q, so you can draw the another radius vector which is denoted as R bar. Now here because of this change in radius vector, you will find there is a one angle which is called as the plane angle. Because of the changing position of this position vector or the radius vector, you will find the next terminology as angular displacement. Angular displacement, and this angular displacement is denoted with theta. So you can observe here, this is a theta, that is an angle between the two radius or position vector. That is the angle traced by the radius or the position vector in a given time. It is called as the angular displacement. Now what is the unit of this angular displacement? So we can take the unit of this angular displacement as the radian. So angular displacement, it has a unit as radian. So already in the 11th standard we have seen the radian, it is unit of the plane angle in the fundamental quantity. Similarly we can write the dimension for this terminology also. So you will find the dimensions of this term, it is written as a 0, means it is the dimensionless quantity. So if we know the displacement, we can find out the next, that is angular velocity. Angular velocity. Now this angular velocity is denoted with omega. This notation is called as the omega. Now we know the definition of the here also, the velocity. How we can define the velocity? Velocity is displacement divided by time. Similarly here we can explain, how we can explain the angular displacement? We know the angular displacement, we can make the definition for angular velocity. That is the rate of change of angular displacement with time. That is called as the angular velocity. So you will find this is a formula which can be written as omega is equal to d by dt of theta. So this d by dt, it is called as the in terms of derivative. It is called as the in terms of derivative. So what we can say about the unit of this angular velocity? So unit is taken as radian per second, because angular velocity is the ratio of angular displacement divided by time. So unit will become radian per second. What we can say about the dimension? So dimension you will find here, it is a t raised to minus 1. T raised to minus 1, because L raised to 0, M raised to 0. So you will find this will be the second terminology, that is the angular velocity. If we know the angular velocity, then we can find out the next terminology, that is angular acceleration. Angular acceleration. This angular acceleration is given with the notation alpha. This is given as the alpha. How we can define this alpha now? The rate of change of the angular velocity with respect to time. So we can write this formula, alpha is equal to, again in terms of derivative, that is a d by dt. So change in angular velocity divided by time, it is given in terms of angular acceleration. So the rate of change of angular velocity with respect to time, it is called as the angular acceleration. Okay. Now what is the unit of this and what are the dimension for this terminology? So if you observe, the unit will become radian per second square. So definitely dimension will become L0 M0 t raised to minus 2. So you will get idea about this, that we have seen the radius vector, angular displacement, angular velocity and angular acceleration. So you have to remember these are notations as the first angular displacement as theta, secondly angular velocity as omega, and thirdly angular acceleration as alpha. So you have to compare these two motions, due to which you will get these are the two different types of motion. So when we consider above, this is the circular motion. Again this circular motion, it is divided into two types. Circular motion चे परत पुढे जाऊन दोन प्रकार पडतात. One is called as the UCM, which is a short form for uniform circular motion. Uniform circular motion, it is called as the UCM, and second type is called as the non-UCM. So it is called as the non-uniform circular motion. So in case of the uniform circular motion, it is a circular motion, but when the particle is moving along the circumference of the circle, the speed of the particle will remain same. Means here you can consider that is a linear speed or angular speed. It will remains constant. It will remains constant. While in case of non-UCM, this linear speed or angular speed does not remain constant. I will give the one example. In case of UCM, we can take the example that is a motion of moon. That is the motion of moon. Now when we consider motion of moon, it is continuously revolving around the earth. So the speed of that moon, it is the same when it is moving about the earth. In case of the non-UCM, you can consider the example that is vertical circular motion. Vertical circular motion. आता vertical circular motion कुठे पाहिलेलं आहे? You have seen merry go round. जत्रेमध्ये यात्रेमध्ये आपण जे पाळणे बघतो, ज्याच्यामध्ये या पद्धतीनं वर्टिकल सर्कल, काही पार्टिकल वरती परत खाली येतो आपण, तर त्याला आपण वर्टिकल सर्क्युलर मोशन असं आपण म्हणणार आहोत. आता इथं परत तुमच्या लक्षात येईल, if we know the analogous term, then definitely we can find out the such type of the kinematical equations in the scalar form in case of the circular motion. So how we can find out these kinematical equations in case of this circular motion? So this is also the very important part. But before that, you should know as all these are the vectors. All these are the vectors. Similarly, all these are the vectors. Now definitely we know when all these are the vectors, it require magnitude plus direction. Magnitude plus direction. But when we consider about these kinematical equations, here only we are thinking about their magnitude. So it is called as the scalar form. But how we can find out the directions of these vectors, that is theta angular displacement, omega angular velocity, alpha angular acceleration. So all of these three, the direction is given with the help of the right hand rule, and it is a very important rule by using which you can find out the direction of these vectors. So suppose if we consider this is nothing but the motion which is drawn in the horizontal plane. So let it be this is the center, let it be this is the position vector of the particle. In this direction you will find